Hello, everyone, and welcome back to another episode of CleanTechies, the podcast. On today's podcast, I spoke with Sam Ruben, the Chief Sustainability Officer at Mighty Buildings. We had a really interesting conversation today, just kind of two Midwestern boys having an interesting conversation regarding the technology that Mighty Buildings has developed and is continuing to grow. In summary, what they do is they 3D print buildings that are they're very, very sustainable. Obviously, there's a little bit more that they're going to continue to develop to make them a little bit more sustainable than they already are. But basically, they create these prefabricated buildings that are quite interesting looking and quite cool, actually, very, very sleek. And they're helping to solve the housing crisis. So very interesting conversation today with Sam. I hope you enjoyed today's episode as much as I did shooting it. And as always, today's episode is made possible by NextWave Partners. All right, Sam, welcome to the podcast.
Oh, it's a pleasure to be here.
Yeah, thanks so much for joining us. So I guess just for everybody listening, do you want to just give us a quick rundown on your background and how you ended up with Mighty Buildings?
Certainly. So prior to starting Mighty Buildings, I was working as a sustainability consultant. Otherwise, probably I'll take you even further back. So did my undergrad in political science and economics at Vassar College in Poughkeepsie, New York. Found myself back in Michigan and then worked my way out here to California, where I spent a number of years working in interfaith peace building, which is kind of in its own way, kind of social sustainability. Before that was really a big buzzword. And even though I really, really enjoyed that, decided it made sense to go back to grad school. And so ended up going to Presidio Graduate School, which is based here in the Bay, which is one of the first programs in the world to center the entire curriculum around systems thinking and sustainability. So I ended up getting both an MBA as well as an MPA, so public as well as business administration, with a focus on sustainable management. And then so at the time that we founded Mighty Buildings, I was working as a sustainability consultant, helping organizations optimize their bottom line by reducing their impacts in terms of waste, water, energy, transportation, and the like. So a lot of that would be looking at building envelopes, helping the organizations understand their energy usage patterns, identifying places where maybe their HVAC was popping on randomly at 2 a.m, or their cleaners had a bad habit of leaving the lights on, but all the way to things like, what's it mean to move a garbage can 10 feet? What's the impact on waste generation? So essentially doing behavioral change as well. And that was always fun because you'd set up a garbage can, wait a week, weigh it, first sort it to see what kind of contamination you had, then do it again, and kind of try in different spots to kind of see what is the actual impact, then use that to then actually create a model. And so what I would do with the clients was focus on identifying opportunities, modeling out the impacts of those opportunities, but just as importantly, modeling out the business impacts. So what is to really empower them to be able to make that business case up to their C-suite? Because you can be the most sustainable, socially conscious company in the world, but if you're not making any money, you're not going to have any impact. And that's really for me where that whole idea of triple bottom line and kind of maximizing impact while balancing the needs of people, planet, and profit is so core to sustainability, and even really beyond sustainability into resilience and regeneration, which, if I'm being honest, is where I'd much rather the conversation was, but it's not quite there yet on a broad level.
Got it. Yeah. So I guess, so with Mighty Buildings then, could you maybe give us a background on kind of what exactly you guys are doing, explain the technology in kind of brief, understanding that the average person will be able to understand it?
Certainly. So we're a construction technology company. We're a startup based in Oakland, California. Our original location was just across the bay here in Redwood City, where we started in a third of a warehouse in the port there, which was kind of fun. We started there because one of our fellow Y Combinator alum was based there. And so we started by sharing some space with them when we were in Y Combinator, and then moved over here when we were ready for a full scale operation. And so what we've done is we've developed a unique 3D printing technology for use in the construction sector. And your listeners and viewers have probably read or heard a lot about the rise of 3D printing in construction and seen some great stuff out there. And a lot of what they've seen is concrete. And essentially is just a different way of pouring concrete. Mm-hmm. We're taking a completely different approach. So we've actually created a completely unique material and unique printing process that, instead of using temperature and time like you do with concrete or thermoplastics and most of the 3D printing that your layperson is familiar with, we actually use light to trigger the hardening process. So what that means, so an easy way to think about it is, if you've been to the dentist recently and been unfortunate enough to have a cavity, there's a decent chance that the dentist, instead of like back in the day where they put like gold or amalgam or something like that, put a little liquid in there and then shined a little flashlight on you. Mm-hmm. That's what we're talking about, but to make a building.
On a big
So
scale.
very like essentially it's like literally same concept where you've got a resin, where you've got a polymeric substance combined with light to trigger the hardening process. But the material itself that we use is called a thermoset composite. And so what it is, essentially it's a synthetic stone that's created using polymers, and a bunch of mineral filler. And we've also now are in the process of moving into certification a new version of the material, which also incorporates continuous fiberglass reinforcement to increase the strength profile, allow us to reduce the amount of material being used, and also should open up the pathway to moving into multi-story properties and projects. So where we are now is we've started delivering accessory dwelling units, so backyard granny flats, in-law apartments. They go by a variety of names. And the reason we did that, and so those have been so far direct to homeowners. And the reason we chose that market as our initial market is the state of California has really streamlined the permitting process for those types of units with a series of legislation going back to 2017. Well, legislation was originally passed in 2016, but went into effect starting in 2017. Yeah. But our vision and where we've started to move with the new project that was recently announced in Rancho Mirage is to be a tool for the industry and to really be a platform that builders and developers can use to unlock the productivity we need in the industry to solve the housing crisis, but to do so in a way that doesn't exacerbate the impacts on the climate crisis, given that construction of buildings is 11% of all GHG emissions, building energy use is another 28% of all GHG emissions. And I don't believe either of those figures factor in waste generated during the construction phase, nor end of life waste generation and the impacts on carbon of that.
Got it. Okay. Yeah, that makes sense. So I'm curious, where do you get, how does the actual physical product itself that you print, like, where does it come from? Again, you said it's a resin base, like, are you able to recycle other things? Is there carbon sequestration involved? Like, how does that process look?
Great question. So where the material itself, where we are now, we're still in our electric vehicle phase, insofar as the upfront embodied carbon is higher than we want it to be. That said, with this new material that I mentioned, we're moving into certification. We're already able to achieve a 20% savings over our previous version. And additionally, this is a part of our roadmap because we've committed to being carbon neutral by 2028. So we're really making a pretty bold and audacious goal there. And frankly, it's because that's what we have to be doing. Like, this whole idea that we can wait till 2050 to be carbon neutral is insane. Like, I mean, have you read about the West Antarctica ice sheet? And the 10 feet rise guaranteed just from that alone, and that's almost definitely going to go. Like, we like 2050 is way too far away. So if we feel strongly about that. So we've made this bold commitment, and even beyond that, we have a plan of being carbon negative by 2040. And so what that means in terms of what we can do now and around sustainability is, because we're using 3D printing and we print only what we need, we're actually able to achieve close to zero waste production. So about 95%. Of the waste that you would normally have in a traditional stick build, which averages about 3 to 5 pounds per square foot, we're able to eliminate and avoid completely. We're increasing that, working on increasing that upwards of 99% diversion by adding the ability to capture powder from our material, because one of the cool things about our production process is the printing is just the first step. And so because of the unique nature of our material and the fact that it is able to cure very quickly using light, means that we can print unsupported spans, we can print curves, we can print unique shapes. So that opens up a possibility of doing not just the floors and walls of a structure, but the roof as well. And also introducing things like freeform design, or the ability to do traditional aesthetics. So it really opens up a wide variety of opportunities in terms of what the design can look like. And then once it goes from the printer, it then goes into a finishing cell where we're using robotic arms that have been used that people you've seen in automotive and aerospace and many other uses.
Yeah.
And so we're able to use that both for secondary quality control, because we do have integrated quality control in the printing process itself, to scan the object or the module, confirm it matches the digital file. Then we're also able to create a toolpath from that to use a CNC, because even though our material is really strong, it's still soft enough that it can be milled using CNC heads that are normally used for metals like aluminum or copper. So what that means is we can leave the raw print, which some people really like and are willing to pay a lot of money for, to have done using traditional materials. We can mill it smooth, so it's like a stone-like finish. Or it opens up possibilities of doing things like making it look like brickwork, or making it look like siding, and really, again, adding to that design versatility. And so one of the things we're working on now is the ability to capture that powder from the milling process and reuse it as filler. And so additionally, we're also working on spray attachments to allow us to automatically apply paints, primers, stucco, other coatings, and also another attachment to fully automate the pouring of the foam insulation into the interior cavities of the modules and the objects and the components. And so what that means in terms of sustainability is so we've already identified an end-of-life solution. We can grind up our material, reuse it as filler. And that is something we do incorporate into our design phase, both in terms of the units themselves, as well as the new material development, is we do incorporate a full life cycle assessment going cradle to cradle, because it is our goal to be diverting from landfill, even at end of life, in 50 to 100 years when that comes up. And so that's one of the things that we're really excited about now, is that ability to avoid that 3 to 5 pounds of waste, which ends up being 2 to 3 tons of carbon for 1,000 square foot unit, just from the waste that's not being generated. Additionally, because of our ability to deliver high quality units that are cost competitive, we can incorporate solar and battery backup to achieve zero net energy while still being competitive in pricing against similar quality units. So that's something we're really excited about, because that's another 400 kilograms of carbon a month that we're saving the homeowner, and through the ability to achieve zero net energy, on top of the benefits in terms of cost of ownership, as well as obviously all the other benefits in terms of resiliency, particularly here in California, where we regularly have power shutoffs due to during fire season and other impacts. And so this has all been around our ADUs, but where we're going with this platform and really working with builders and developers is projects like the Zero Net Energy community that we've announced down in Southern California, as well as in the future moving into the ability to do density, vertical density with low-rise 2 to 3 story townhouses and like 3 to 6 story low-rise apartment buildings. We may go higher in the future, but right now we see those as kind of the next phase in terms of stepping into multifamily and being able to provide that density in urban and suburban areas on top of kind of the more single-family developments that we're currently able to deliver.
Yeah, I'm curious about two things mainly after all of that is A, when you do start doing larger projects, how's that going to look for the construction phase? Is it still going to be printed and then delivered, or is it going to be an on-site type of printer situation? Like, how does that look?
Yeah, so it will depend on the needs of the specific project, but the idea is to have a distributed network of production facilities, what we call mighty factories, spread across the country and across the world, so that we're actually locating them near areas where the demand is, so that we're able to still leverage the benefits of prefabrication, leverage the benefits of working within a controlled environment, which is a much safer environment for the workers, able to ensure a much higher level of quality control in a closed environment, and also allow us to take advantage of idle capital. Because one of the cool things about using 3D printing and robotics is that we don't need to set up in millions of hundreds of thousands or a million square feet somewhere that's way away from where our demand and our workforce is. We can take advantage of existing warehouses in urban areas, in areas where there's demand, whether that's urban, suburban, exurban, and near where the labor force is. I mean, here in Oakland, we're in an old Pete's Coffee warehouse. That's a 79,000 square foot warehouse. Of that, only 50,000 square feet is production space. And so that's something we're really, really excited about, is that opportunity to take warehouses otherwise are sitting empty and be able to spin up a factory in 3 to 6 months at a relatively low cost compared to traditional advanced prefab. And so our goal there is having partners in those areas who can provide that volume and allow us to serve those communities and create a new class of jobs for those communities, while also making sure we're not exporting California's insane construction costs to other places.
Yeah, I was actually curious about that too. Is the workforce, right? Because I'm curious. I actually grew up with a dad who built houses, so this is very interesting to me. So, what does it look like in terms of the workforce? A, like, how many people does it require? Is it less labor intensive? B, are there ways you guys are helping to upskill other workers to come into this space?
Yeah. So one of the realities that we're facing across the country and across the world, but that's particularly acute here in California, is we don't have enough people to build all the housing we need. Just full stop. Like that's the reality. I think it's something nationally. I was talking to a professor at the University of Denver Burn School, and he was saying something like 400,000 construction jobs open across the US that no one's taking. And here in California, we lost most of our skilled labor force from the construction sector in 2008. Those that stayed or came back tended to be older. They're now retiring. And for every 5 that are retiring, we're getting 1 person into the industry who's has maybe a quarter of their skill set. And so that's the reality we're trying to build millions of houses on. And so it's not surprising we're only building about 100,000 a year when we need to be being literally millions of houses. So first off, that's the problem we're trying to solve right now. And so our goal isn't to replace workers. Our goal is to unlock the productivity of the existing labor force. So at the end of the day, we're only planning on automating about 80% of the operations, because there's always going to be operations that make sense for humans to do. And so what we're looking to do is reduce per unit labor hours by as much as 90%, but overall actually create more work by increasing productivity by as much as 20% or 20 times rather. And so that's kind of how we're really trying, how we see it is because we're trying to get all these units built by leveraging the existing labor force, while also then giving new generation workers who are currently going into programming, going into the gig economy, the opportunity to work with the latest and greatest in technology and come into the construction sector where many of them would have ended up in previous generations, but aren't now because it doesn't give them a chance to work with technology. Generally, the realities of an on-site build are difficult, dangerous work. Some days you don't even know if you're going to get paid because it started raining. And so by leveraging the best of prefab and bringing 21st century technology to bear on it, we're able to take the most difficult and dangerous parts of the build. I mean, framing of houses, I believe, is the second most dangerous job in America after mining, something like 3,000 or 4,000 injuries and deaths a year. No reason we should have humans doing that. Give that to the robots, give that to the printers, really focus on the parts that make sense for humans to do, that need that touch, human touch, and that finesse, and the things that, frankly, we do a lot better than any robot to ever come into existence. Or they require that thinking, that creativity. Like there's amazing opportunities to still take advantage of those skill sets that we have and need, while also attracting that new generation of workers that are going to be so necessary to moving the industry forward in the future. In terms of actual jobs, it ends up being, I think, a single shift. It depends on how many printers we're running, but about 20 or so per shift.
Okay, very good. So yeah, it's just definitely, it's very good for the economy. This is a thing I think is interesting is, you know, I grew up in Wisconsin and just very
nice. I grew up in Michigan.
Place.
So
okay, nice. Go Packers, I suppose, right?
Go Lions.
I don't mind the Lions, to be honest, but
I don't mind the Pack either. So my brother lives in Madison.
Very nice, very nice. Yeah, so the thing I always heard growing up is people complained about kind of this renewable energy and just kind of this revolution of clean technology as costing people jobs. And I just thought it was interesting when I finally realized on my own that, you know, this is actually almost always positive for everybody. Like people are safer, people are getting good jobs. We obviously, there's going to be some transition for skilling.
Oh yeah, you have to train, and we're working on things like apprenticeship programs, working on what does it look like to create, make sure that the people that new generation has the skill sets that necessary. Like those are all things we're very excited about.
Yeah, and I think I'm just always baffled by how amazing it is that these technologies exist out there that are just like pretty much positive all around. I don't see like there's not really much negative going on. So it's interesting. I wanted to maybe have you talk a little bit more about the total, because you talked a little bit about the carbon footprint and how much you're reducing. Could you talk about the scale of that? You know, once you guys are able to scale this to what it could be, what is the potential impact here globally on carbon emissions?
Well, I mean, if we're able to achieve what we're planning on, which is the goal, we're hoping to be able to build about 1 million units over the next 15 years, or essentially get each mighty factory to the point where it can generate 1,000 units a year. So we're looking at potentially, I'd honestly have to go back and look at the numbers, but incredibly, like we're talking about the potential to impact 40% of the global emissions, or well, a sizable chunk of 40% of the world's emissions.
Got it. Yeah, very good. That's what I think. It's just so crazy how positive these things can be. I'm also curious, you know, again, California has pretty good climate most of the time.
Yeah. So here in California, sorry, go ahead.
Yeah, I was just basically asking, like, what about other places like Wisconsin where it's really cold, right? Are these well insulated? Are they sustainable in that regard? I'm assuming so, but I'd just like to hear more about that.
Yeah. So one of the exciting things, and one of the reasons we chose California, is that it has such a wide variety of climate zones. I mean, yes, we've got Death Valley, which is the hottest place on Earth, but we also have Tahoe, which gets over 200 inches of snow in some years. So and gets cold. I mean, it doesn't get northern Michigan or northern Wisconsin cold. But at the same time, we've designed it to work well in California. We're already exceeding California's energy code in terms of energy efficiency. So like a 6-inch panel on our units, like the one you see behind me with our old material, is about R21. Our new material, I believe it's currently being R25, I want to say, and we're looking at identifying improved and more sustainable insulation opportunities that can help us move past that, because it's my goal to get us around R40 or something to really get into super high efficiency. We're already very energy efficient, but I want to get us into like super energy efficient. But that said, so the cool thing is, if we need to adjust it for a more extreme climate, just make the walls thicker. So we just change the file a little.
Yeah, that's crazy because yeah, if you can get to, I think the house my dad built was, I think we got an R30, 35 or 40, somewhere around there. Is he liked insulation for sure.
Yeah, no, insulation's
Um,
like a well-insulated building is great. And in more moderate climates, like the unit behind me you see here is one of our uh, Duo Bs that we delivered in San Diego. And even though it's not certified, there's a very good chance that it actually qualifies for Passive House,
got it. Okay, got
even
it.
even with all that glazing.
Yeah, nice. How I'm curious about this. I'm assuming you guys have thought about this too. Is how easily is it to integrate solar panels in like a Tesla battery wall or something, power wall?
Incredibly easy. That's how we designed it, and that's for multiple reasons. One is because that's just what's needed and what we
Mhm.
believe in. Two, California now, as of last year or the year before, or no, as of the beginning of January 1st, 2020, requires solar on all new residential products.
Oh, really?
And
Wow, that's
they
interesting.
would have actually gone as far as requiring zero net energy, so including battery storage on all projects. But California has a cost effectiveness test for mandates, and because of the cost of battery storage still, they couldn't
Yeah.
mandate that people had to have it. That said, I could see that changing pretty quickly with some of the advances we're seeing in battery technologies and some of the reduced costs that we're anticipating coming down the pipeline in that regard over the incoming years.
Got it. Yeah, that makes sense. That makes sense.
But yeah, like our units that in Rancho Mirage will come, all of our units come solar ready, if not with solar. And all the
Mhm.
units in the project in SoCal will have both solar and Tesla battery walls.
Wow, very nice. That's amazing.
And that's what's allowing them to capture that step into zero net energy.
Oh, okay, got it. Yeah,
Because you have to
100%.
be able to generate as much on-site as you use in a year. And frankly, to really do that properly, particularly with usage at night, if you're using solar, you have to have battery. And that also adds resiliency in the face of the realities of the power shutoffs and everything that we have here in California due to the fires.
Yeah, for sure. Yeah, it's interesting to see how this is going to shift. So, I guess next thing I'd be curious about is what are some of the big challenges and things that you guys have overcome, whether it's legislation or specific technology issues. Like, I'd just be curious to hear the things that you guys have overcome. What have been the biggest challenges in general?
Yeah, well, being in the construction sector, one of the biggest challenges is always going to be the regulatory environment and the inherent conservative nature of the industry. And it's well deserved. I mean, the simple fact is the building codes exist because they're sadly written in blood. I mean, they were created because things went wrong and people got hurt and people died. And that's the reality. So it makes sense that the industry would be somewhat conservative and very, very safety oriented, which we've completely agree with and completely respect. So as a result, well before we ever came out stealth mode, so very early on in our existence, we've actually been focusing on the regulatory side. So we've been working very, very closely with UL, Underwriters Laboratories. And the reason we chose them instead of ICC or ATMO or Airtech or one of the other evaluation services is that not only does UL have over 100 years of building life safety, they also have some of the world's leading experts in additive manufacturing. So that means we're uniquely situated to understand our technology and then look at what does it mean, what does it look like to show code compliance. So what we did with them is we went through a whole process of creating an evaluation report, which has served as the basis for their new standard, UL 3401, because no one had ever evaluated anything like what we're doing for the use in the building industry. And so UL 3401 is the world's very first standard for the use of 3D printing in construction, of which we're the first and so far only company in technology certified under. Additionally, it's been added to the 2021 International Residential Code update that'll be published next year as an adoptable appendix, meaning that jurisdictions, everything from countries down to small villages and towns that utilize the IRC as the basis for their residential code, can take that appendix and plug it in. And even those that don't formally adopt it can still look to it for guidance. And a similar effort is underway to have it added to the International Building Code as well, to also expand that for commercial use as well. And so we're really, really proud of our work with UL and our efforts to help bring 3D printing into the code. I mean, in doing so, we've essentially brought it into the code in about 2.5 years. And beyond that, we're also working closely with ASTM. In fact, I'm the chair of their subcommittee on the development of new standards for the use of additive manufacturing in construction. And so that's a consensus-based process working with different players from the 3D printing industry in terms of material producers, manufacturers, companies like us are deploying it, other companies that maybe are using it in order to create something that's really robust and really brings all those different viewpoints to the table. And so that's something we're really excited about and has been something that we take to heart. Additionally, we've made practice of engaging with local building officials well before we're ever getting ready to pull permits, because we want to make sure that we're engaging with them and understanding their pain points as much as possible, and also understanding that our goal at the end of the day is to try to make their lives easier, because that's really what we're trying to do here, is because building officials, they know they need more housing and they want more sustainable housing, and we want to make sure that they're seeing us as a partner in that, and not some stereotypical tech company that's coming in and trying to flout the rules and just do things regardless. That doesn't work.
Yeah, I think that's a good point, because it's like, you talked about the conservative nature of the regulations in this industry, and I think that just goes to show kind of, we had this industrial movement, obviously, that it was build things and just build this massive piles of wealth for certain people and everything. And it was kind of throw safety to the side. Right now, we have all these safety measures. Now it seems to me that a lot of the companies innovating in this space, particularly in clean tech, are focused on way exceeding those, right? Making it actually, let's build good things. Let's help fix the environment, and let's make it a very safe place. Well, what are you seeing in that, like, in terms of like other companies doing this?
Yeah, well, in terms of the 3D printing construction space, it's clear that it's an idea whose time has come. I mean, just for like when you look across like both the country and the globe. Here in the US, we've got a number of different companies that have either been pioneers in the space or who are now stepping into the space. Contour Crafting out of LA, I think they've been around since the early 2000s. And we're actually responsible for working with ICC and creating AC 509, which is the acceptance criteria for the use of 3D printed concrete, which has since been more recently updated in partnership with Black Buffalo out in New York, which is actually a division of Hyundai, I think, or somehow connected with Hyundai, to include multi-story. You've got Apiscore, which is based out of Boston in Russia, has been doing some really cool stuff. They have a 2-story building they printed in Dubai. You've got Icon out of Austin, which is becoming famous for their low-income and homeless housing in Austin and Mexico. You've got Branch Technologies out in Tennessee, which is doing some really cool stuff in terms of, they've got this technology they call CFAB, which is being used for 3D printed facades. So it kind of like creates a cellular structure that they then fill with foam and then cover that with cement. And then that gets put up on a wall. And so there's a bank that's got the very first deployment of that. You've got SQ4D out in upstate New York, which is doing 3D printed concrete houses. I'll leave my opinions on the quality of the sides. And I'm sorry, there's some of the pictures that that they've put out. I'm like, I don't understand why you would ever let that go public. But
understandable.
That said, I love that they're selling it on Zillow. That's amazing. So I like all credit to them. You've got like a print farm down in Florida, which is doing 3D printed like sheds and stuff. You've got New Genesis Dimensions, which is working with the U.S. Army and deploying 3D printed concrete homes. So most of it's been concrete, and those are just the U.S. ones. Like getting into Europe, you've got Cobod, which is doing some really some amazing stuff, similar to Black Buffalo in terms of developing printers, which are then sold or leased for projects. They're doing both Cobod and Black Buffalo are doing some really cool stuff around that. And you just had a new 3D printed home in the Netherlands, which it's like a ranch style home that someone just moved into. So it's a really exciting time. Like global. And that's how WASP, which is doing and it's got some of these Italian companies that are doing really cool stuff with clay and local material, like truly local material. Yeah, and so it's like just seeing it across the board is just, it's amazing. It makes me just really happy. But it also speaks to why it's so important that we're creating a regulatory structure, because if any of these new companies, if something goes wrong, and they're not that's not just going to set that company back, that's going to set the entire industry and the entire technology back by potentially decades at a time when we can't afford that. And so having these standards and regulations in place means that at least there's a framework so people can know how to do it safely and know how to do it correctly. But also, if someone does it the wrong way and something happens, we can then point to that and be like, yeah, but they didn't do it right. They violated this, and this, and this. We're doing it differently. We're doing it the right way. We're following the rules, and really make that clear to at least mitigate some of the potential damage to the possibilities that are there with 3D printed construction. And because obviously I'm incredibly biased, but I really, really do believe that 3D printing is one of the best tools we have in our toolkit right now to help solve the housing crisis in a sustainable way. And let me know, not in a sustainable, in a resilient and regenerative way. Because I'm really being honest, I hate the word sustainability. I like nothing about the status quo does not need to be sustained. We've already passed so many points of no return. It's going to require resilient systems and resilient technologies that can deal with what's coming down the pipeline. but what they're also regenerative and can help kind of build things back, like get us back to where we
To
need
get to this, to get to
to
the
help undo
circular
some of the
economy.
to help undo some of the damage that we've already been doing. But I mean, what the reason I can still have a smile on my face and what gets me up in the morning is that belief in human ingenuity. I mean, the fact that we have this, humans have this amazing ability to come up with whole new ways of doing things that change everything and that we never could have imagined until the moment we created them. And it's usually by accident. Like my favorite example of this I just read about was, so apparently like 5-10 years ago, whatever, a Japanese baker, so apparently a Japanese baker wanted to create an algorithm that could allow it to be easy for not have individually wrapped or packaged pastries, but also still be easy for that to be scanned, automatically priced and scanned. So you're not, as the barista or the counter person, you're not having to come up with what the solution, like, okay, remembering what the price is, especially when we got 20, 30, and you can really focus on the customer interaction and the part that humans make sense for. Turns out, so it took them 5 years to create this AI, this algorithm using AI and machine learning. Works wonderfully. You know what it also works wonderfully for? Identifying cancer cells. Because it's the same. So like, this is like my favorite example about something that has changed the world in the just in the last 4 years or whatever, that originally was created to tell a bear claw from a cinnamon bun. And now it's being to determine cancerous from healthy cells, and really speed the process of diagnosis. And so that's amazing. Like those examples, I mean, everyone, like the Post-it notes is another great example, even though they're very useful, but maybe not world changing.
Yeah, for sure.
And silly putties is also one of my favorites. But
I think, I mean, this just generally speaks to, I guess, the thing I wanted to maybe get your thoughts on a little bit more is kind of the human aspect, right? Like, obviously business is business, capitalism is going to, be needed to help us make this change in reducing our carbon emissions and everything. Obviously Tom Rand, you guys are backed by, you're invested in by Arcturn, correct?
Yep.
Yeah. So obviously,
we're lucky enough to have Arcturn as one of our climate-focused investors.
Yeah. For people listening, I highly recommend reading Tom Rand's book, Case for Climate Capitalism, where he talks about this. But just generally speaking, I'm very keen to get your thoughts on the human aspect of, we're obviously doing this for a purpose, right? We're not just doing this because we want to save the environment. We live in the environment. And I think that, the way companies are run can sometimes be really bad, right? They can treat their employees badly, et cetera. So I'm just curious in what you think clean techs in the industry in general, what our role is, and kind of given our purpose to create companies where people are respected and treated well. Like, could you talk a little bit about that?
Yeah, no, that great question, and something. And so, I mean, God, there's so many things to unpack in there. Because I mean, at the end of the day, like, technology itself is neither good nor bad. It's amoral. It's up to us how we as a society and how we as companies choose to utilize it. So that's one. So there's a big social question that needs to be a part of any conversation, which kind of speaks to this fact that if you look back at starting in the late 70s, I think is when we saw productivity and wages decouple. And at that same time, so that's when we started really embracing technology. But we didn't do so in a way that actually made sure we benefited the people that you're at the bottom of the pyramid, as it were. And so that was a choice. And so there's this whole, I think that's why we're having these conversations socially about universal basic income and these other things, because at the end of the day, I mean, Buckminster Fuller back in the 50s was talking about how we had technology such that one person can do the work of 10,000 and that we should be freeing the rest to do things that further humanity. It's even more acutely true now. And so I think there's a big social conversation to be had. Like, as a society, how do we want the benefits of technology to, who do we want them to go to, and how do we want them to be distributed, and in what way? So that's one conversation that needs to happen. And that's a social, that's even beyond the clean tech. I think clean tech has a big role in being a voice within that, because we're often the ones that are bringing this technology to bear in ways that are seeking to be as positive as possible. And so I think it's kind of imperative on us to make sure our voices are in that conversation. But that conversation's happening. I mean, we're seeing pilot projects happening across the country and across the world in what does it look like to create universal basic income and to begin to decouple this work from worth, and in terms of human value. So that's one part of it. I think another part of it is this idea that we and then again to the amorality of corporations. I mean, this whole, because there's this idea legally in the United States that corporations are people. Yet the corporations as people don't seem to have the rights of people, but don't necessarily seem to have the responsibilities of people. Because you can't throw a corporation in jail. Like there's only so much, like you're like can't like so that gets very complicated and interesting as well. And I do think people in clean tech are generally looking beyond a standard bottom line and really are looking to that triple bottom line and looking to like, what are the impacts on people? What are the impacts on planet? Obviously needing to have strong impacts on profit as well, or else you're not going to have any impact because you won't be in business. But I think there's a huge opportunity for companies in the clean tech sector to lead by example, to kind of step forward. And I think we see that across the, like in a lot of cases, like we see companies that not only are trying to do right by the environment, but are trying to do right by the communities they impact and their workers. And then you get down to just the simple business case. Set aside everything you want about ethics and morals and all that. Sustainable business is good business. More resilient in the face of ups and downs of the market. More resilient in the face of climate catastrophes. Generally are dealing with a situation where, particularly if you're looking at the people aspect of it, happier workers are more productive workers. You have less turnover, less training costs, less loss due to internal theft. Like so many things brought impacts in that regard. Like so, at the end of the, and that's going back to my what I did before Mighty Buildings. Like that's what I would do. It's I'd make the business case, and like I talk about the operational efficiencies, because that's the other thing is resilience and regeneration, sustainability. In a lot of cases, it's operational efficiency. It's removing waste from your processes, because that's how we get to be more sustainable as we reduce. And so I know I'm kind of starting to ramble a bit, but yeah. So it's no, very like we could spend an hour on any one of those facets.
Yeah,
easily,
I know. So. I know it's tough. I just think that it's quite interesting because because of the, people oftentimes they're just so driven by, at least to me, it seems like it's shifting now, but they're just so driven by making as much profit as possible. And they're so focused on such a short-term aspect that you got to remember these things play out, right? Companies rise and fall oftentimes based off of how people are treated, because you need people. Even as many robots as we get, as much as, Elon Musk gets us this AI stuff or whatnot, we're still going to need people, right? Mm-hmm. So
and people are still going to be around. Well, I mean, speaking to that, it's again, going back to that idea of productivity and wages decoupling in the late 70s. I mean, that's also about the time we were at when you had a shift in the stock market from a focus on long-term profitability to short-term profitability. That's not a coincidence. I mean, there's a reason that you've had multiple times Warren Buffett and other people writing letters being like, dudes, we need to stop caring about what's happening, whether we're going to be profitable next quarter, and start caring whether we're going to be profitable in 5 years. Like, exactly. And because that focus on short-term profitability over long-term profitability introduces incredible volatility into the markets, because it incentivizes CEOs and others to take risks that they often are not going to be around to deal with the consequences of. And so you've got people getting insane golden parachutes, and then the company goes bankrupt because of their decisions. Like, we've got a really screwed up incentive structure and I think that's really, because I mean, this is where my econ undergrad comes in, because like econ, at the end of the day, you want to understand why people behave a certain way, figure out what's incentivizing it.
Exactly.
Whether it's intentional or not, there will be an incentive in place that is creating that behavior.
Yeah, 100%. I think I guess I would just say to everybody listening, again, we all need to hold the clean tech sector accountable to this. We have to push and drive for these things, because we have an opportunity where we're already entering a space where people are much more open-minded in general. So use that to try to fix things that have been wrong for a while. So yeah, I guess, one more point
before we move on from that. And that's why I do think that, speaking to your point about we have a kind of responsibility in the clean tech sector, that includes making sure we're incorporating diversity, equity, inclusion into what we're doing, and that we're providing opportunities for historically marginalized communities, and that we're providing, in a lot of cases, and that's why things like apprenticeship programs and training programs and identifying those and like engaging with those institutions that are serving those communities in a way to help elevate that. Like, because I think the only way we're going to get where we need to be is if we're ensuring all voices and all viewpoints are part of those solutions, or else we're going to come up with solutions that don't involve the entire system and and lead to unintended consequences that can be incredibly negative long term, without us even though the intentions behind them might be nothing but the best.
Yeah, I totally agree. All right, so yeah, just to kind of wrap up things here, I want to maybe end with, What are some of the things that you're most excited for in terms of other technologies in the clean tech space? What are the things you're looking for, trends you see are coming? What are you excited for?
Batteries. I think batteries, like from everything from little batteries to giant batteries. Like I think new battery technology is really going to unlock so much. Everything from some of what I've been seeing in the last couple of weeks with some of these new solid state batteries that are still able to leverage lithium ion anodes and use lithium ion infrastructure, but are much safer and more stable and able to bring costs down. I was recently seeing one about structural batteries where it's like something like 3D printed carbon fiber batteries that are essentially massless because they're actually serving as the structure of the car or whatever it is and not adding any additional weight to create the battery. It's just taking advantage of the existing weight that's already a part of whatever it is. So those, and then obviously opportunities for micro-sized batteries, really fast charging, but then getting into large scale using old tech. I mean, so on an industrial scale, I get really excited about things like compressed air, like using salt caverns and using compressed air to create steady state batteries, or using big saltwater flow batteries in combination with lithium ion peaker batteries in order to create a demand response on energy, on utility scale energy production. I mean, we've seen some amazing things with that types of setup in like Texas and also in like Australia as well. So I think batteries are on the verge of a revolution, and I mean, that's people have been saying that for 5 to 10 years now, but feels like it's really true now.
Yeah,
And yeah,
I feel like we already are in it because, like, again,
yeah,
in the perspective I have, obviously a lot of innovation happening. I think that the technology is there to help reduce peak demand and everything like that with all these, massive utility scale batteries that are placed in strategic locations for municipalities, et cetera. But yeah, that's interesting. Yeah, I think that, again, obviously, as everybody knows, like, we need, in order to complete the circle, to have constant energy that's clean, we're going to
yeah.
need batteries. We're going to need energy storage. I think
And it doesn't have to be high tech.
it doesn't have to be. I mean,
Like that's
like
the part that's really
hydro.
exciting.
Yeah, I think a good example of it is also Arcturne invests in them as HydroStore. If I understand correctly, they have a pretty interesting technology that's very, very simple, but can produce these very long-term, energy for long-term demand. So, but
Yeah, I
yeah,
mean,
well,
pumped water storage, pumped air storage, like really simple, like gravity storage. That's a fun one, where you basically just have a mine shaft and you use energy to produce during the day to lift a really heavy object, and then at night you let it go and use the kinetic energy. It's amazing, basic physics.
mhm. Yeah, absolutely. Well, anyways, it was a pleasure having you on, Sam. I really appreciate you taking the time out of your day and for joining us. And yeah, we'll see you on the pod hopefully another time in the future.
Yeah, my honor and a privilege, and really enjoyed the conversation. Look forward to next time.
Yeah, thanks. Awesome. Thank you guys so much for joining on today's episode with Sam. Please definitely go follow and connect with Sam on LinkedIn. Follow what Mighty Buildings is doing. Obviously, some very interesting stuff. Perhaps you're interested in purchasing one of their buildings. Very, very cool stuff. I highly recommend you check out their website, what they're doing. So quite affordable and very interesting sustainable housing. Also, if you enjoyed today's episode, please do like, follow, subscribe, comment your thoughts. We're really curious to hear what you think of the podcast. Any ways you'd like to see us improve it, suggestions you might have for future guests, whatever it might be. Always would like to engage with you in the comments. So please do that. And if you're interested to continue learning more about the clean tech space, you want to get more involved, maybe meet some people directly, you can also go join the Slack channel that we have created in the description as well, and connect with many professionals around the world in the clean tech space there. Also want to take a moment to shout out to NextWave Partners as our long-term sponsors of this show, who NextWave Partners are specialist headhunters in the renewable energy, technology, and clean tech sector, who, again, they make this show possible, but what they really do well, oh my gosh, fucking awesome, guys. Thank you so much for joining us on today's episode with Sam. I hope you enjoyed it as much as I did. Obviously, it was just a great conversation. So many interesting things. Would love to hear your comments and thoughts on what we talked about. Any suggestions for future guests, whatever you're looking to hear, definitely drop them in the comments. Love to interact with you there. Also, if you're interested to be more involved in the clean tech space, you want to meet some people and just kind of understand what's going on, feel free to join our Slack channel, which is also in the description. and you can just connect with many different professionals in the clean tech space from around the world in there. And yeah, please do share this as well with at least one person that you think might find this interesting. What Mighty Buildings is doing, what clean tech things are happening to help curb climate change. Want to take a quick moment to also thank our sponsors, NextWave Partners. NextWave Partners are specialist headhunters in the renewable energy, clean tech, and technology sectors globally, who specialize in specific searches. We do retained searches. NextWave can also oftentimes be a very good partner to help you set up in a new market, whether you're building a new company or setting up in a new place that you're not as familiar with the market. The specialist headhunters at NextWave can help you to know what's going on the ground and help you to get that leg up on the industry in that space. So reach out to NextWave Partners for more information at info@next-wavepartners.com. That's info@next-wavepartners.com. And another quick announcement too is we have coming up at the end of May, we will be having our first newsletter. CleanTechies, a newsletter is coming out. I'm working with a friend of mine to produce this, and I'm very excited for that. So definitely go to the link in the description to sign up for the newsletter. It's going to be a monthly newsletter, and we're going to hopefully get some good content in there regarding deals that have happened, kind of some thoughts on the industry, and just some general things that's not going to clutter your inbox. It'll be, once a month with some good hard hitting content that'll hopefully help you to continue to learn and to keep up on what's going on in the space. So again, thank you guys so much for joining us on today's episode with Sam, and we will see you next time on Clean Techies, the podcast.